In this screen capture, I'm going to show you how to complete the NBA project. And I'm starting here from the Sketch NBA MVP template. That's the file I supply that's got a lot of what you need in it, but not all, since you have to add some code to actually make it work. Let's start from the top. The key to this is the data that are in the program. So you don't have to read these data from a file or pull them from a web page. They're right here in the program, in the code, in the sketch, in the form of a two-dimensional array. You can tell that it's two-dimensional. It has rows and columns because it has two sets of square brackets, one for the rows and one for the columns. If you look down at the data, you'll see that there are 13 rows starting from 0, and each of those rows, row 0 has the names of the columns, but rows 1 through 12 have the names of a player and then a whole bunch of statistics about the player. We're going to make a two-dimensional graph, an XY chart, a scatter chart, those are all names for the same thing, that shows one player characteristic on the X and another player characteristic on the Y. And to do that, we're going to pull the data out of this two-dimensional array. Before we do that, we can look at some setup stuff. For instance, in the setup method, I have already corrected this before. This said wide and high, and I fixed that because processing will no longer accept that form to be 500 by 500. You can change this however you want, but I'm going to use 500 versus 500. I set the background to black, and it says no loop because this is a one-time program. It runs, it draws a graph. That's all there is to it. Doesn't need to do anything over and over again. Doesn't need a draw method. Let's label the X and Y axes so we know what we're plotting. Now, right now they just say X and Y, which I guess is okay, but a better thing to do would be to put data from the data array from NBA data row 0, which is the row that has the column names in it. And so for X, let's use the player age. If we go up here, row 0, 0, 1, 2, 3, column 3, counting from 0, is the age. So here's that says go into the NBA data array, go to the first row, take the third column, and use it to label the x-axis. For Y, let's use points 1. So that's NBA data 0 because we know the column labels are in row 0. And I think it's column 6. 0, 1, 2, 3, 4, 5, 6. Points 1. Okay, so we'll put that here. So that should label the X and Y axes as we go. In fact, this is a good time to test out the program. It's not complete, it's not going to do much, but it's good to test as you go along. I think we should see a black window, I hope, with two labels, an X and a Y on it. Let's run it and find out. Yep, there's the x-axis, shows the labeled age, and that's the y-axis is going to be going down this way, and that's showing points 1. So far, so good. Let's use the loop to complete the rest of this. You can see here how you get data out of the NBA data array. You give numbers, subscripts, indexes in the square brackets to pick the data you want. We can do that down here, but instead of getting everything from row 0, we're going to get everything from row number row. Row is going to count from 1 to 12, so it's going to go through all the players in order. Curry, Harden, James, and it's going to make the data in all the columns available, or whatever columns we select, for that player. So let's create a couple of variables here, which is the easiest way to do it. We need an X and a Y, because we need two coordinates to plot with. This is a lot like what we've done in class. Let's make them floats. So float X and float Y. We can ignore the warnings for right now about not being used because we're about to use them. And then X gets NBA data row. That's going to automatically do row 1, row 2, row 3, row 5, up to row 12. And for, we said X was age, and that was column 3. So we're going to do this. Now that's not quite correct yet. You can see it's underlined in red, means there's a mistake. That's because we're trying to put a string, something in quotes, up here, like the player age, into a numeric variable, like a float. But we can tell processing to fix that for us. And all we have to do is tell it, hey, we want this to be a float. So make it, you processing, make a float out of this. In the same way, because you know I love to copy and paste and change, I'm going to copy that line, paste it back in, change it to be Y, and that's again row by row, but for Y we need column 6, which is the points 1. Let's see if those values make sense. Now, when we run this now, the graph won't look any different because we haven't drawn any shapes on it yet, right? Let's try it. Nope, still looks the same. But if we draw some shapes on there, we can actually start getting a graph. So in the meantime, let's print out the values and let's just see if they make sense. So the print line command will print text down here in the text area. Not in the display window, but down here. It's handy for debugging. So let's print line x equals plus x, and then let's print line y, quote, y equals quote plus y. And when I finish making typos, that will work. And that should show values that should show us what x and y turn out to be. And the ages should make sense as ages, and the points 1 should go from like 1,000 down to just a handful. So let's run that. Again, the display window won't look any different, but you'll see a bunch of values down here. Yes. If I scroll back here, you'll see that 26 must have been the age. That must be Curry, a couple of years ago, and 1,198.1. So those values make sense. So I think now we can go ahead and try to draw some shapes in the window. You probably remember how to draw shapes, and you can do circles, you can do rectangles, you can do whatever you want. I'm going to do rectangles. So I'm going to do rect. And if you remember, the rect method wants 4 numbers. It wants an x, which we have just calculated, a y, how high and how wide, and let's make them 10 pixels by 10 pixels for now. That's kind of arbitrary, but let's see what happens. So now when we run it, we should see some squares on the graph. They may not be in the right place, may not be pretty yet, but they'll be there. Let's run this. They're there. Now they look weird. If you think about it, that's because there's a problem scaling here. The points 1, well, they go from like 1,000 to a very small number, so that's why they're strung out this way. But the ages, I mean, all these players are pretty young. You get to 35, you're done in basketball, right? This is 500, so these are probably all clustered around here between 20 and 40. Is there a way we can stretch those points out and make a more illustrative graph? Yes, there is, and that's the map function, which is mentioned in step number 3. So we're going to apply the map function to x and y to stretch those values from or compress them from the range they're in to a range that fits squarely on the screen. The map function looks confusing because it takes a bunch of arguments, but it really is very easy. It does a linear transformation, and you don't even have to understand how that works. You just have to use the function. Let's do this. So let's say x gets map. So the new value of x is going to be based on the old value of x. For x is now this x is the player's age. It's probably between like 20 and 40, and we want to stretch that so it's between 0 and 500, so it will fill out. So take X, if it's between 20 and 40, stretch it so it's between 0 and 500. That's what map does. Same thing with Y, so we have different limits. The new value of Y is the old value of Y. Y goes from like, I don't know, 0 to 1500. And we want to compress, in that case, that between 0 and 500. Where did the 500 come from? Remember, that's how big I made my display window. And then we'll print the new X's and the new Y's, and we'll use those values when we print the graph. So let's run that. The points are more spread out, which makes more sense. Now you might ask, well, who's who? I can't tell which point means what. We can fix that too, because if you remember our experimenting with the text function, the function way back in the windshield program that draws text on the screen, we can draw text beside each of these rectangles, and we can put the player name in there. So then we can tell, at least the last name, we can tell who belongs to what point. So let's do that. So let's do text. If you don't know how these work, you can always look them up on the processing web page. It wants a string. Well, it wants NBA data for this row, and the player name is in, last name is in column 0, 1, 2. So we want to do row and column, row. I know it sounds crazy. And row 2. And it wants to know where to put it. If we put it right at X and Y, it's going to be on top of the rectangle. So let's try putting it at X, I don't know, plus 10 and Y plus 10. As you remember, in many things with graphical programming, there's a lot of trial and error. So what this statement says is, go into NBA data after you calculate exactly where the rectangle squares should be, and pick up the last name of the player and drop that alongside the corresponding square. So let's see how that looks. Okay, I didn't line it up perfectly, but it makes a lot more sense now, right? Here's Curry with thousands of points, and he's still comparatively young. And we've got some folks crunched up at the top. We could probably fix that with a little bit of better scaling, but we're going to leave that. I'm going to leave that to you to pretty this up. Okay, I'm just going to get the basic one going. And this is the basic thing. It's got all of the elements. It's got the X and the Y, and it's got the names of the players on there. Could you make it different colors? Yes. Could you use different symbols? Yes. Could you make it a lot neater than I did by aligning things more carefully and moving things around? Yes, you could. And I'd like for you to do that. But in the meantime, this is the basic idea for how you use a two-dimensional array to hold data, which is what this project is really all about. So at this point, I'm going to let you take over and see what you can do with this program.